Hi guys, welcome back to another video session with EasyChem. Today, our video is going to focus on reactions of carbonyl compounds. This is a part 2. We did part 1. You can find the part 1 video using this URL. Please go ahead and do it so that you will understand the entire reaction set that you are supposed to know under aldehydes and ketones. In this video, I'm trying to focus on 3 reactions of only aldehydes. 3 reactions of aldehydes with the solution 1, acidified potassium dichromate solution. Second one is Fehling solution. And the third one is Tollens reagent. Fehling solution is also known as Benedict solution. And Tollens reagent is known as ammonical silver nitrate solution. However, in the first video, we talked about 3 reactions. But those 3 reactions are shown by both aldehydes and ketones. Not only ketones or aldehydes. It's important if we go through the reactions we have discussed once again to remember. So the reaction shown by both aldehydes and ketones, according to what we have learned in video 1. The first one is reaction of aldehydes and ketones with hydrogen cyanide in aqueous medium. The reaction happens at the presence of KCN because KCN breaks down in aqueous medium, producing cyanide ions, CN minus. Cyanide ions are going to act as catalysts, and the product of the reaction is hydroxynitrides. And in the second reaction, we talked about how aldehydes and ketones react with lithium aluminium hydride in dry ether or NaBH4, sodium borohydride in alcoholic medium to produce primary alcohols by aldehydes and secondary alcohols by ketones. Remember, lithium aluminium hydride and sodium borohydride are both reducing agents. And number 3, this is a really interesting reaction because reaction number 1 and reaction number 2, they don't give any color changes during the reaction. But reaction number 3, when you add an aldehyde or a ketone into this solution called 2,4-dinitrophenol hydrazine, the shortened form is 2,4-DNPH, you get yellow, orange, at least at times red as well, precipitates of 2,4-dinitrophenol hydrazine. Remember, this 2,4-dinitrophenol hydrazine structure has to be remembered for the exam purpose. And if you go through the video 1, you will see, you will know how to construct 2,4-dinitrophenol hydrazine structure very accurately. These are the things we have done in the video 1. In the video 2, we are going to discuss about only 3 reactions of aldehydes. The importance about these 3 reactions is that we can identify aldehydes from ketones using these 3 reactions. You can say reactions with acidified potassium dichromate solution. We will look into the details of them in a while. Reactions of Fehling solution and reaction with Tollens reagent is going to be the third reaction to discuss in today's video. Because these 3 reactions, reaction number 4, 5, 6, are going to distinguish aldehydes from ketones, it's worthwhile going through the nature of these solutions a little bit. I mean, the appearance of it. You should know as a chemistry student the colors of these solutions and the observations as well. You can see this acidified potassium dichromate solution. It has one of the most beautiful colors that you can see in a laboratory. Really beautiful. And then the second one is Fehling solution, Benedict solution. It's blue. And then Tollens reagent, ammonical silver nitrate solution. It's a totally colorless solution. Let's see more about the reactions of these solutions with aldehydes and ketones. Before we move on to the reactions, the 3 reactions, we should know one thing. It's about Tollens reagent. This colorless Tollens reagent, if you want, you can buy that in the market, or else before a test, you have to make the Tollens reagent in the laboratory. It's a very simple thing. It's a matter of just mixing 1 or 2 solutions. You end up with a Tollens solution for your experiment. We'll see how we can prepare a Tollens reagent for a test, aldehyde test in the laboratory. Preparation of Tollens reagent in the laboratory is one of the easiest things that a student can do in the laboratory. It's pretty simple. What you do is you take a silver nitrate solution and add some sodium hydroxide bit by bit, drop by drop, until you get a brown precipitate. The pictures will show you how it is done. You add sodium hydroxide into silver nitrate solution little by little until you see a brown precipitate. You can see the brown precipitate in the third picture very well. Once the precipitate is formed, brown precipitate, you add ammonia solution little at a time, ammonium hydroxide, while shaking the content. And then you have to stop the addition of ammonium hydroxide solution when the brown precipitate dissolves completely to give a colorless solution. You can see in the extreme right-hand side, a colorless solution. Can you see at the very beginning, we get silver nitrate solution, which is colorless over here. In the second picture, you can see when you add sodium hydroxide bit by bit or drop by drop, some brown precipitate is formed. And you can see very well in the third picture, a thick precipitate has been formed. Now, in the fourth picture, you can see ammonium hydroxide solution or ammonia solution is being added into this test tube containing the brown precipitate. In the fifth one, you can see the precipitate has dissolved very much. It's almost clear now, but you can see perfectly clear solution in the last picture. What you can see over here is the Tollens reagent. You can use this Tollens reagent to test for aldehydes or ketones, actually to test for aldehydes, to distinguish aldehydes from ketones in the laboratory. Let us see the reaction of aldehydes with potassium dichromate. Our first reaction to discuss today. What will happen when an aldehyde is reacted with orange potassium dichromate? When acidified potassium dichromate solution is warmed with an aldehyde, we can do it in a water bath because aldehydes can catch fire if you try to use naked flame. So we have to use a water bath, warm the aldehyde mixture with potassium dichromate solution. You can see the aldehyde, whatever the aldehyde you are using, going to carboxylic acid. One example is here, ethanol. Ethanol has 2 carbon atoms, 2 carbon atom containing aldehyde. See what happens when this ethanol is going to change to the carboxylic acid is ethanoic acid. You can see the difference between ethanol and ethanoic acid. That will tell you exactly what has happened during this reaction as well. Here in ethanol, we have carbonyl functional group over here attached to hydrogen. But this particular part has changed when it comes to ethanoic acid. The H plus is no more there, but we have an OH. Now, initially, the reaction is orange because the potassium dichromate we are adding is orange. But during the reaction, what happens is, you can see slowly, the color of the solution change into green. Why do you think that this orange solution is going to green during this reaction? Because there's a redox reaction happening. A redox reaction is happening. We'll see how exactly this happens. We can discuss this further by taking another example, but this time I'm going to use another aldehyde, butanol. Butanol is an aldehyde having but 4 carbon atoms with the functional group at the end. Always aldehyde functional group appear in the corner of carbon chain. So we have butanol here, 1, 2, 3, 4 carbon atoms. This butanol, you can figure out what is going to be formed now. Butanol goes to butanoic acid. Butanoic acid also has the same number of carbon atoms. See what has happened? Hydrogen over here has gone to OH. During this reaction, you can see earlier also we discussed orange solution goes to green. Why do you think it is so? Butanol, when it goes to butanoic acid, you can see an oxygen atom is coming into the molecule, changing the aldehyde into carboxylic acid. Because an oxygen is getting added into this, it is an oxidation. When an oxidation reaction happens in a reaction system, definitely there should be another substance which undergoes reduction. Actually, it is a potassium dichromate that undergoes reduction. You can forget about potassium and take dichromate ion. Dichromate ion is orange, Cr₂O7 2 minus. And I said dichromate ion is changing to, in a reduction reaction, it's going to change to a green solution which contains chromium 3+. You can calculate and see later. Oxidation number of chromium in Cr₂O7 2 minus is +6. And here, +6 oxidation number of chromium has gone to chromium 3+. And also this oxygen is also going out. Removal of oxygen, reduction in oxidation number, they are both reduction reactions. So you can see potassium dichromate ions going to chromium ions, chromium 3+ ions, by reduction. Let's move on to the next one now. We introduced to the 3 types of reactions we are going to discuss in this video at the beginning. The 4th reaction shown over here, acidified potassium dichromate solution. We have done the reaction. And then we have to go to the reaction of aldehydes and ketones with Fehling solution. We'll see how Fehling solution is going to react with aldehydes, not with ketones. Okay. Even though potassium dichromate solution is an orange thing, Fehling solution is not orange. You saw the color earlier. Bendic solution, another name. Fehling solution is blue. Why is it blue? Because we have Cu2+. Characteristic blue color of copper-2+ is in the Fehling solution. You saw that earlier when I got the bottle next to this label last time, remember? And this Fehling solution is an alkaline solution. Copper-2+ ions are there, the medium is alkaline. When an aldehyde is warmed with Fehling solution, remember the Fehling solution is blue, it also has to be done in a water bath because we are testing aldehydes. Aldehydes are flammable, so you can't use naked flame. Always we have to have a water bath for this. What's the observation? The blue solution produces a brick red precipitate of, this is called copper-1 oxide. Copper-1 oxide is a brick red precipitate. You can see the blue solution producing a brick red precipitate in the test tube. Here I have just drawn a diagram to show you what happens here. On the left-hand side, you can see a test tube kept in a water bath. And the blue solution is actually a mixture of Fehling solution and aldehyde. And when you warm for some time, you can see the test tube, the color of the test tube, actually the content in the test tube going from blue to brick red. By doing this experiment, very conveniently we can identify if a substance is an aldehyde or a ketone. Let's talk about this reaction of aldehydes with Fehling solution a little bit more. You remember in the first reaction we talked about, the reaction of aldehydes with potassium dichromate, it was a redox reaction where aldehydes undergo oxidation and dichromate ions undergo reduction. In a similar manner, the reaction of aldehydes with Fehling solution is also a redox reaction. What happens? Aldehydes undergo oxidation, while solution has copper-2+ ions, they show reduction. How is it happening? I'm going to react copper-2+ ions. Copper-2+ ions means Fehling solution. You react Fehling solution copper-2 plus containing Fehling solution with propanol. You know what happens? Propanol will go to propanoic acid, and copper-2 plus will go to copper-2 plus will go to copper-1 oxide. Copper-1 oxide plus propanol will give propanoate. Actually, it makes propanoic acid, but because the medium is alkaline, you end up with propanoate. If you do a simple calculation for the oxidation number of copper in Cu₂O, you will see the oxidation number of copper is +1. See, on the left-hand side, it is +2. On the right-hand side, copper oxidation number is +1 in this oxide. So if oxidation number goes from +2 to +1, it is definitely a reduction. When a reduction happens on copper here, propanol has to undergo oxidation. It's a very, very clear explanation to identify this reaction as a redox reaction. We can discuss this further using another example. This time I'm going to use copper-2 plus ions, in other words, Fehling solution, with ethanol, 2 carbon containing aldehyde. In this also, copper-2 plus ions change to copper-1 oxide. And then ethanol will change to a carboxylic acid. Can you guess the carboxylic acid? Propanol gives propanoate. Actually, ethanol gives ethanoic acid. And then because the medium is alkaline, you end up with ethanoate. Now, this reaction also a redox type where copper-2 plus ions change to copper plus. In copper-1 oxide, oxidation number of copper is +1. So this is a reduction. Why do you think reduction happens? Because there is another reaction where oxidation occurs. Ethanol goes to ethanoid ion. It is an oxidation reaction. These reactions are as simple as that. I think we have finished 2 reactions in our lesson. You can see first one we discussed was acidified potassium dichromate solution. Second one was a reaction with Fehling solution. And we have to do the 6th reaction, which is about reaction of aldehydes with Tollens reagent or ammonical silver nitrate solution. Remember I told you earlier that this Tollens reagent is something also known as ammonical silver nitrate solution. It's something we always make in the laboratory before an experiment. This solution, Tollens reagent, contains silver ions. And it is also in alkaline medium. And this has no color. When an aldehyde is formed with Tollens reagent, which is colorless, this also has to be done in water bath. Remember, all the 3 reactions we discussed today are done in water bath because we can't use direct heat since aldehydes are flammable. What happens when you heat with Tollens reagent in a water bath? You can see a silver mirror formation due to the formation of silver atoms. A very, very small amount of silver atoms will be formed, and these silver atoms will deposit on the test tube, giving a silver mirror. You can see colorless Tollens reagent and aldehyde mixture. You get this solution. You can see it's fully colorless. It's a mixture of Tollens reagent and aldehyde. You can see beautiful mirror appearing on the test tube. Silver mirror formation occurs on the test tube if you heat a Tollens reagent with ammonical silver nitrate. Now, the reactions of ammonical silver nitrate with aldehydes are also redox reactions. We are going to discuss about the 3rd type of redox reaction, where what happens is aldehyde, as usual, aldehyde undergoes oxidation and carboxylic acids will be produced. In the meantime, there are silver ions, I said earlier. Tollens reagent contains silver ions. These silver ions undergo reduction because aldehyde undergoes oxidation. We can take one reaction to discuss this. You can see here, silver ions, colorless, react with propanol. If propanol is going to undergo oxidation, you think what sort of a compound will be produced? propanol will produce propanoic acid, and silver will undergo reduction. What will happen in that? Reduction happening on silver plus means silver metal is formed. See, +1 oxidation number of silver plus has gone to 0 in silver metal. And in the meantime, propanol is going to make propanoic acid, but the medium has an alkaline substance, or else the medium is alkaline. Therefore, you end up with not propanoic acid, propanoate. If you write the reaction of Tollen's reagent with carboxylic acid produces carboxylate ion, that's fine, it's understood. And see what happens here. In this reaction also, silver plus, I told earlier, Ag plus goes to Ag0. It undergoes reduction. When silver cations undergo reduction, the aldehyde undergoes oxidation. To get this idea firmly into the mind, we will discuss about another reaction. In this reaction, I'm going to talk about the reaction of Tollen's reagent with ethanol molecule. Now you know what's going to happen. Silver plus, according to the earlier equation, silver plus go to silver by reduction, and ethanol will produce ethanoic acid, but actually what we see in the reaction is ethanoate. Observe it clearly. Silver plus goes to silver in reduction. Ethanol goes to ethanoate in an oxidation reaction. These are basically the reactions which are happening in these reactions. But it's always worthwhile after a reaction, a set of reactions like this, to go for a summarization. Here I can summarize the entire thing. Please wait till this work is over. Propanol, 3-carbon containing aldehyde. We are discussing about aldehyde reactions. First, remember, with potassium dichromate, propanol goes to propanoic acid. The reaction happens when you heat this propanol in a water bath with acidified potassium dichromate. If you use heat and reflux, that's fine. This is actually to make a big amount of a sample. And this is not for testing. This is for converting propanol to propanoic acid. I'm not talking about, earlier I talked about testing for aldehydes. Here I'm talking about converting propanol to propanoic acid. It's a very simple thing. At the same time, propanol can react with Fehling solution as well. When you react with Fehling solution, propanol is going to make, remember, propanoate. We can't make propanoic acid because the medium is alkaline. So propanoid is formed. The conditions for the reaction and reagents are Fehling's reagent and heat. We can heat it in the water bath. Do it with the next one now. Propanol, last reaction. It is a reaction with Tollen's reagent. In Tollen's reagent, there are silver ions. Propanol undergoes oxidation to give propanoate. Tollen's reagent has to be heated with aldehyde in a water bath. In addition, remember, there are observations. Why propanol undergoes propanoic acid? Why propanol undergoes oxidation to make propanoic acid? Because we have potassium dichromate, oxidizing agent. So oxidizing agent undergoes reduction, finally producing chromium 3+ ions. So the solution slowly goes from orange to green during the reaction. And in the second one, Fehling solution contains Cr₂O+. And during the reaction, what happens to Cr₂O+? Cr₂O+ makes red-brown copper 1 oxide precipitate. And then finally, Tollen's reagent makes silver atoms by undergoing reduction. And these silver atoms, they are going to deposit on the test tube wall and give us a beautiful silver mirror. Now, remember guys, it's very important that these reactions, they often come in your exam papers. So that is a very, very strong suggestion that I would like to make here. Study these reactions well. Learn how to write reactant and product structures. Know what reagents are going to be used, what conditions are used, and the reasons as to why we use these conditions and reagents. And also, all these three reactions are of redox type. And most importantly, you should know why we discuss these reactions. It is because these three reactions are used to distinguish aldehydes from ketones. Okay, well, guys, now this concludes today's video. Thank you for learning with EasyChem.